Professor Veera, you are able to join.
Yes, sir. Now only I am able to join.
Yeah.
You were asked to join at 4:30.
Yeah. I mean, something went wrong. Yes.
Yeah.
Well, good evening to everybody. We are going to have a webinar that is the 6th of the series of International Road Federation webinar. And this is on new age and perpetual pavement for performance and economy, technology and design methods for eliminating any major maintenance of road pavements. That's the basic theme. And Professor Veera Raghavan will be the moderator. Professor Veera is the former professor in civil engineering at IIT Madras. He is uniformly recognized as one of the top-ranking pavement professionals, both in India as well as abroad, also both in academia and industry. He was and is involved in pavement research in many institutions in the country, and therefore he has an unique position in the profession due to his involvement in both sides of the profession. He is the recipient of Pandit Jawaharlal Nehru Path Centenary Award of IRC, CIDC Vishwakarma Award, and many others, about a dozen of them. He has more than 200 publications in referred journals and conferences. He is also co-author of a few books in civil engineering. In his long experience of more than 4 decades, I had also a few opportunity to work with him in few of the fields he works on. Professor Veera has prolific teaching, research, and field studies credentials with exemplary records. I invite Professor Veera Raghavan to moderate the webinar. Professor Veera. You are muted. You are muted.
Thank you, Professor Sikdar. I have a very long association with Professor Sikdar for over nearly 4 decades. It's a pleasure to moderate this webinar on the new age and perpetual payment for performance and economy, technology and design methods for eliminating any major maintenance of road payments. So we have today 2 eminent speakers, Mrs. Atasi Das from the GR Infra Gurugram. Mrs. Atasi earned her bachelor's in civil engineering from Jadavpur University and master's from the University of Delaware in the USA. She has over 25 years of experience in India and USA. She specializes in pavement materials and geotechnical engineering of highway infrastructure. She's a passionate woman highway engineer whom I have met in the last several decades. She has successfully implemented several new initiatives in pavement construction, perpetual pavement, bonded rigid pavement, ground improvement using geosynthetic, sustainable technologies like the use of IRF, warm mix additives, polymer modified binder for long-lasting pavements, cemented bases and sub-bases, composite pavements, stabilized embankment accommodation subgrades, She has done an exemplary work in slope stabilization measures in Himachal region. Mrs. Satasi was awarded the prestigious CIDC Vishwakarma Award for the Innovator Award. She is a member of many technical committees of IRC, ICS, and associated in formulation of and updation of codes, guidelines. She has co-authored more than 50 technical papers in national, in international journals and conference proceedings. Welcome, Mrs. Satasi. I also have with us today, Dr. Nikhil Sabu. Nikhil Sabu was earlier with Banaras Indian University. He moved to IIT Roorkee as an assistant professor. And this year, he has been promoted as an associate professor in the Department of Civil Engineering at IIT Roorkee. He has more than 12 years of experience in teaching research in the area of payment engineering. Nikhil is a very passionate teacher cum researcher. He has extensive experience in research as well as industrial consultancy. He has published more than 60 technical papers in science-cited journals, Scopus-cited journals. He has delivered more than 40 technical talks and several topics in the domain of payment engineering. He has coordinated, or he has been coordinating, several research projects with a budget of more than 6 crores. He is a member of several national and international committees like the IRC, Bureau of Indian Standards, APSC, RILAM, TRG India. He is also in the editorial board of the journals like as ICE, Institute of Civil Engineers UK, Construction Materials, Advances in Civil Engineering, Indavi. So welcome, Nikhil, for this webinar.
Thank you, sir.
To set the tone for this webinar, as everyone is aware, a perpetual payment is a bituminous payment that is designed and built to last long. I am not mentioning the years, generally 50 years, without requiring a major structural rehabilitation or reconstruction. The payment is expected to have or require only periodic surface renewal in response to distresses that are confined to the top of the payment. Payment thickness design is made based on the assumption and the principle that the payment should be able to resist bottom of fatigue cracking and deep structural rotting as the two modes of structural failures in the payment. And it is assumed or presumed that by limiting the radial tensile strain at the bottom of the bituminous layer and the vertical compressive strain on top of the subgrade, these two distresses can be prevented. So this amounts to selection of materials, thickness design for the expected traffic for over 5 decades. This also requires a high quality bituminous binder. Maybe to resist friction, maybe open grader friction course may be required. A deep rut resisting upper binder course with a high modulus, crack resisting lower binder course is also needed. So these payment advantages being low life cycle cost, low user delay cost, low environmental impact, and therefore can be considered for the Indian highways. I also appreciate IRF Indian chapter for having taken up this chapter when India has taken up several mega projects in the road sector. But there are a few challenges which I request Dr. Mr. Atasi and Dr. Nikhil to address. Challenges being design traffic, as well as the traffic estimation. What are the expected growth that we should consider? Number of lanes, distribution of the loads and the axle load spectrum for the next 5 decades. There will be new technologies in vehicle. Where will be varying axle configuration? How do you address this to estimate the design traffic? Second, we need a performance engineered asphalt mixtures. Their moduli, it varies, and hence the strain value and therefore the fatigue life and performance. And there is nothing like a unique HMA fatigue algorithm. Therefore, how to address that? Third is the fatigue endurance limit, wherein we understand that increasing the thickness beyond the limiting thickness will not provide any structural response resistance to fatigue damage. This fatigue endurance limit is not the same for all mixers. So therefore, will the specific mixers that we are adopting in India for the DBM and the BC will meet the requirement of performance engineered asphalt mixers? If not, what is needed to ensure a perpetual payment? Next comes the issue of structural design moduli. As per the IRC, the moduli values can be around 3,000, 4,000 MPa, but the Texas report says the nearly 6,000 to 8,000 MPa is per payment. How do you address that? What should be the rut resisting binder course mix? What should be the choice of wearing course? All these are to be linked. We can do laboratory experiments and model using computer software, but how to link theory to practice? How to account for the variability in the field when we construct? What's the design thickness? What should be the maximum pavement thickness should we address? How do you address the distresses due to supporting layers, subbase, base, granular or stabilized, subsurface drainage, performance prediction? These are other issues. But when we talk about the tensile strain and the radial tensile strain and the vertical composite strain, will we be considering the bonding issues, shear failures, moisture-induced damages, top-down cracking, or they address the perpetual pavement? There will be many more new materials that will come in the next 5 decades. How do you account that in the design? Finally, quality of construction matters. The proof of the pudding is in the eating. How do you address the quality-related performance factors? And more importantly, when these highways in the next 5 decades, 4-lane will be converted into 6-lane to 8-lane to 12 lanes, is so this 4-lane or 6-lane, when we design the perpetual pavement, when we widen it, upgrade it to 6-lane or 8-lane, how do you balance the rest of the lanes? Should they be perpetual pavement or can be conventional pavement? I think Mr. Satasi has already executed a perpetual pavement. So I am always for reverse engineering. So let Ms. Satasi share her experiences on the design and construction of the first perpetual pavement in India, which will be supplemented by the theory by Nikhil. So over to you, Mrs. Atasi, to take us all to the wonderful area of perpetual pavement. Mrs. Atasi, please.
Good evening, sir, and very good evening to you. I'm not sure if you're morning there or you are back, but good evening to everyone. So, I mean, today I would like to present not only perpetual pavement, I will cover that briefly, but it will be more of the other types of pavements that we are having currently in India, and we are going to have in the near future, because that's where we stand. And let me share my presentation. So is it visible?
Yeah, it is.
Is the presentation visible?
Yes, it is. It is visible.
Okay. Okay. Yes, sir. Yes, sir. So,
Atasi, you're muted.
yes, sir. So, I mean, it is about the new age technologies in pavement applications that currently we are having. So briefly, I would cover each type of pavement in design, the design aspect, then life cycle cost analysis with the enhanced life, because there are so many types of pavements these days. So we need to have an like idea of the costing as well, or the life cycle cost that it it may implicate. Then the innovations in design optimization, innovations in bituminous or concrete mixtures, then construction techniques, accelerated rehabilitation also. Because what we are going nowadays is that the stakeholders or users are demanding like safer, long-lasting and sustainable infrastructure. But the overarching goal should be savings in the life cycle cost and not the initial cost. I mean, there is a like paradigm shift, it appears, that we are like thinking only of the initial to economize the initial cost of construction, means whatever the life cycle cost, Armejai type of thing. We should not do that. Saving now and paying later is plain, simple, irresponsible act. So we should be responsible engineers and think of the life cycle cost instead of the initial savings in the cost of pavement. So in 2001, the ME design approach incorporating material properties came in, and we started using the stabilized pavements in 2010, then 2013 use of alternative materials, then 2014 use of falling weight deflectometer. That's how the upgradation in the pavement technologies went. 2014, we started using the foam bitumen technology, then 2015, the use of the wrap. I mean, though in a small scale, like using small dosages, it came in, then cold recycling, hot recycling, it came in 2015 only. Then 2019 expansion in the usage of geosynthetics when IRC SP 59 was revised and came in. Then 2019 only we started the construction of the long life or the perpetual pavement. Then 2022, it started the construction of the high dosage wrap. Till date, we had been thinking about like up to 30% recycling, but then we started recycling 50% to 60% hot recycling. And inflexible pavement, then the geosynthetic reinforced pavement and bonded rigid pavement got constructed successfully 2022 onwards. Now the latest practices under construction, we have forgotten now almost the conventional pavement of BC, DBM, WMM and GSB, that is like almost a gone era now. Now what we have is high wrap dosage, that's the recycled DBM. BC we are not yet recycling, but recycled DBM under the flexible pavement system. Then geosynthetic reinforced pavement, then perpetual flexible pavement. Here we still have the conventional system of the layers a little bit. But still we are doing again innovations in these also by making it semi-rigid or the type of pavement and using, I mean, the whole lot of things which should not have been used, but we are innovative in India. Rigid pavement also, we are doing bonded rigid, then short panel concrete pavement, precast, pre-stressed concrete pavement, two-lift concrete pavement, besides the conventional rigid. Then composite pavement, we have rigid over flexible pavement, then flexible over rigid pavement. These are the combinations going on in the industry. And endeavor in pavement sustainability in terms of rehabilitation, because we are just building kilometers and kilometers of roadway, and the widening also we need to take care. Rehabilitation during widening need to be taken care of, as Professor Viraraghavan mentioned, that widening like 4 to 6 laning, 6 to 8 laning, all these 2 laning to 4 laning or 6 laning, this should be taken care of with like a holistic approach towards rehabilitation of the existing lanes also. So we have bituminous on bituminous pavement, that IRC 115, concrete on concrete IRC SP 17, whole lot of codes are there. IRC SP 76 on concrete on bituminous, then bituminous on concrete pavement, it's under development. I just drafted the code yesterday and sent to IRC. Hopefully it will come through. Cement grouted bituminous macadam, that's IRC SP 125, reinforced overlay using geosynthetics SP 59. Then microsurfacing SP 81. Now coming towards the design aspect. I mean, are we like attacking everything with a holistic approach? Well, let us delve a little bit. I mean, January 2024 traffic data we have, and we have supportive traffic data also. Let's study one of the vehicles plying on the Indian roads in the states of UP, Bihar, Chhattisgarh, and all that. It's a sand commodity, and the vehicle type of multi-axle vehicle type is 1.22.22, and I have shown in the figure also, it's a 5-axle tractor semi-trailer. So what the load it is carrying, it is like 96 tons, and the VDF which is coming is 131.68. And this is the, and also the, is our flexible pavement capable of taking these high VDFs? No, our design is not catered towards like designing such a pavement which has a VDF of 131.68. And what is the legal axle load limit as per the, I mean, if we go by the legal axle load limit for this same truck, it is 8.77. So there are questions for many. Will our pavement, flexible pavement, or even for that matter, perpetual pavement sustain this kind of pavement? And with parallelly the environmental condition like ambient temperature, it is rising more than 45 degrees centigrade. So where there are so many guidance we need from the academia. Then perpetual pavement design philosophy, I won't go much deeper into this because the next lecture from Professor Nikhil Sabu will already covered this. But again, we don't have any instrumentation done in India. These microstrain endurance limits have been fixed based on like the foreign countries, and then giving a little bit of the attention to the overloading factor, but not necessarily. I mean, these are as per the instrumentation done in India. So in the name of perpetual pavements, these so many types of perpetual pavements have been constructed in India since 2019, and more innovations are coming. Not that these perpetual pavements are applicable in the rest of the world, but we Indians are really innovative. But are these actually truly perpetual pavement? Well, this will be covered in the next lecture. But why have we been innovative? Let me, walk you through the cost. The cost, I mean, some of these, like the main thing that goes is the wearing course, then binder base course, and we have 3 layers of bituminous courses. Then we should have the WMM, that's the granular base course, and then we have the granular sub base course, the subgrade. This is what is going on in the it should go on as a perpetual pavement across the world and across in India as well. And then, but we have been innovative. We have made CTSB, the GSB as a cemented layer. We have been further innovative, and we constructed the WMM as CTB also. So it has come down to like only the wearing coat, and then only 2 layers of DBM, and then the CTB, the CTSB, the subgrade. Well, is it truly a perpetual pavement? Well, from cost point of view, what we see, these are some of the thicknesses when you come with design. I mean, to reach the endurance limit, these are the thicknesses which achieve the endurance limit. And if I run the maintenance regime on each of these pavements for a period of like 30 years or 30 to 50 years, then this is the comparison of life cycle cost per kilometer in crores for 8-lane expressway for 50 years of design life, considering 18.75 meter each side carriageway width. And then the bonded rigid pavement for 50 years, conventional rigid, flexible pavement CTB, flexible pavement CTSB, flexible pavement conventional. All of this, if we compare, then we see that the CTB, CTSB layer, the innovative layer, comes out to be the cheapest. And that's why people went for a perpetual pavement with this configuration, because even in life cycle cost, it came out to be the cheapest. And now the comparison of initial cost and life cycle cost, because as I said, we should be more like attentive towards the life cycle cost rather than the initial cost. Again, this is the cheapest. In initial cost of construction also, we have the innovative perpetual pavement with CTB and CTSB as the cheapest. The third one from top with 262.25 crores. So people went for it. Whether it was a success or not, it will be covered in the next lecture. And these are some of the pictures from from the 6 packages that we have. Raghavan sir had mentioned that we have constructed, and true, it looks good. The SMA surface really looks good, and I won't go into the now the nitty-gritties of the construction, because I have to cover the other types of pavement. And now coming to the we have done quality tests on these, followed strict quality regime for the success of these pavements. It's not easy to construct SMA because no technical know-how. Technical know-how was very limited when we constructed these pavements, and but we made it a success, and till now they are performing good. Now coming to the next type of pavement, which is the geosynthetic reinforced flexible pavement, which is like, when we came out from, when we moved out from the conventional system of BC, DBM, WMM, GSB, then what came out to be the cheapest option other than that was for any type of pavement, I'm not saying that for a perpetual pavement, for any type of pavement, the next, the cheapest one came out to be BC, DBM, WMM, and CTSB. that's the semi-rigid form. But no, these days we have another cheaper version, which is with the BC, DBM, reinforced WMM, and then we have the GSB. But yet again, another cheaper version came out, which is BC, DBM, reinforced WMM, and then CTSB. But are these pavements again true to its sense of meeting the service life and the design life? Well, time will say, because we don't have the long-term performance in India yet. The design concept of the geosynthetic reinforced pavement is same as that of the conventional pavement system, but it's just that with the introduction of the geogrid, we are giving some form of lateral restraint and improving the bearing capacity, and then also the easing out the load transfer in a wider base. So as soon as, I mean, because the granular base of WMM layer, it is weak in tension, or it cannot take tension. So we are introducing a tensile element in like the geosynthetic, the geogrid, biaxial geogrid, to give it so that it can resist the forces. So that is what it is doing. And say if WMM is supposed to have the resilient modulus value of 350 MPa when constructed over CTSB, or say in the range of 150 to 250 MPa when constructed over GSB. So if we apply the geogrid and give an improvement factor of 1.5 to 2, so it will have an MR value of say 500 MPa or to 600 MPa that comes from design. So we can reduce the thickness of the DBM layer. So that was the goal. But whether it was a true essence of design, well, I mean, time will say, because the performance history is still not there. So what is the construction procedure of the geosynthetic reinforced WMM layer? It is first we prepared it is usually, I mean, when the economics come out is that when it is laid in between the GSB layer and the WMM layer. So preparation of GSB for placement of the geogrid, then placement of biaxial geogrid layer over the prepared GSB, then nailing of J-hook pins to keep the geogrid in position, then laying and compaction of the WMM layer. And sometimes it happens that wrinkles come and we have to do some, I mean, either then we have to lay the WMM in 2 layers, or we have to be innovative now then to, I mean, work with the wrinkles if they form. Then we have the compacted WM layer, and the rest of the construction is like normal conventional pavement. So what is the quality assurance test plan during construction of the geogrid reinforced pavement that we must have, which I mean is being neglected in the industry these days? Plate load test should be done at the points marked, like the red points I've marked. Like there should be a control section, and there should be, compare when we get the values of the MR of the control section, and then we introduce the geogrid in the reinforced sections. And if we have one layer of geogrid in between the WMM and the CTSB on the left side, so there we have to measure the plate load test results, I mean, at 3 points. And when we have 2 layers of geogrid, say our subgrade is poor as well, then we can improve the CBR value as well. And then we have again that to conduct at 3 points, we need to conduct the plate load test. And this we repeat like during the execution process also. I mean, sometimes we may not have the same quality of geogrid supplied to site, and our the MI value, the modulus improvement value may vary. So we need to keep on these quality checking all the time during the execution also, if we to check if our design meets with the execution parameters or not. So that is a stepping stone towards performance. And I mean, if we don't do, then our performance may hamper. So these are the how we do the plate load test. I mean, these are some snapshots, and it is not a difficult test. It's a regular test that can easily be done at site, which people are ignoring sometimes. Now coming to the high RAP dosage by hot in plant recycling. So as I said, I mean, from the 2022 onwards, I mean, these things like recycling, I mean, more than 30% came into the being, because I mean, it requires what it nowadays the HMP plant produces bituminous mixes with fresh aggregates or mix of fresh RAPM. That's the recycled or reclaimed asphalt pavement material. So in India, the bituminous mixes are produced with the ratio of 70s to 30. As I said, 70s to 30 is the norm. With the normal plants, we can produce. High RAP is still not regular engineering in India due to the special bituminous batching plant requirement. Then based on the intended dosage and type of recycling, different plant setups are available. Say if we want to recycle 60% means of the existing, if it is a brownfield project, normally it won't happen for greenfield projects. But if it is a brownfield project, widening project, then we will have ample of reclaimed asphalt material available from the existing bituminous surfacing. So, I mean, what happens is that we have to engage one, I mean, if we want one parallel flow drum, so that we heat up the wrap separately. What is the, I mean, I mean, this is the process we follow for usage of high RAP dosage by hot in plant recycling. First of all, what has to be adopted is two-step milling, not necessarily always, but if you have a thicker pavement in the existing pavement, then you follow two-step milling. The first milling is done on the top 50 mm bituminous concrete. The other milling is done in the bottom bituminous, the base course, that's usually 100 mm or more or less. The milling from the pavement layers are further screened into further sizes and stored in bins. Storage bins are the wrap storage management has to be done very meticulously, so that there is no moisture in the ingress. Steps for a quality wrap product, if we see, it's like I mean, it's like two-step milling, then crush or screen the wrap, stockpile the wrap, test the wrap as stockpile, as per stockpile, use the wrap, then test the wrap as consumed. There are so many steps, I mean, steps if we want to recycle. And for milling drums also, if for two-stage milling, we use fine milling with micro fine milling drums and coarse milling with standard milling drums. Then, I mean, what we do is wrap is heated in a different barrel, like the parallel drum is used for high RAP mixes. Then the heated wrap is added with heated virgin aggregate in the pug mill. They do not mix, I mean, they are transported through different conveyor belts also, and heated at different temperatures in different barrels, and they mix at the pug mill. Virgin binder and rejuvenators are added in the pug mill only, and mixing time is higher in the pug mill to provide a homogeneous mix. In normal, I mean, when we are not recycling, the normal, I mean, mixing time in the pug mill is usually like 18 seconds, 18 to 20 seconds or something. But if we are using this high dosage 60% old materials, then the mixing time has to be increased to about 30 seconds to give well good time for the existing materials to existing like in the pug mill for the rejuvenator to do their work. And now the flowchart, this is the flowchart where the freshly laid where the distressed pavement is there. Not necessarily it has to be distressed also, because when we are widening, it may be good material. We can get some fresh materials as well. Then milling of the distressed pavement or milling of the existing pavement, then screening of the mill material, then stockpiling the wrap, laboratory testing and mix design has to be done meticulously. Then plant production is there, transportation of mixes, the laying and compaction, freshly laid pavement. There are some temperature categories that need to be followed when we are doing all this recycling process. Not that IRC 120 covers everything, but I mean, it touches upon many of the things, but we need to upgrade 120 also based on our experiences soon. Then these are some of the pictures, I mean, of the where we laid the trial patch, and under the guidance of Professor Nikhil Sabu, he did the mix design, the high dosage, this wrap design for us. And we can say, I mean, it is looks as good as a new surface. I mean, you can see from the third picture that, I mean, there is no difference. If it is a fresh material, there is no difference. It's a very good surface with the ran traffic for 1 year before we laid BC. There is no problem at all. Now, coming to a little bit on the cost comparison for the conventional, I will do a little bit rush because of the time. So, I mean, in essence, what we have, the bitumen, the advantages of the mixing plant, this separate plant, is that bitumen film will not be overheated and damaged. Recycling temperature by the dryer outlet at around 130 degrees centigrade, and use of screen not affected. So the essence is that for 60% dosage recycling, you need to put a little bit of expense on the plant. I mean, this parallel flow drum, you need to invest about 5 to 6 crores for that. But there is an ultimate gain. I mean, you need not go to buy 40% of your aggregates will be your fresh purchase. Yeah, we can reduce the bitumen content from 4% to like 1.8% of purchase of fresh bitumen. So ultimately, a savings to the tune of per ton mix production, the savings to the tune of say 700 to 800 may be expected depending on the aggregate price. Now, coming to the new age rigid pavements, we have constructed bonded rigid pavement. Then two lift concrete pavement is in the planning. Short panel concrete pavement also we have laid. Then concrete overlay over concrete pavement, pre-stressed precast concrete pavement, composite pavement. These are the new age rigid pavements now. Now, conventional the rigid pavement has mostly we have seen throughout 300 mm of PQC, DLC is 150 mm, GSB is 150 mm, and the panel size is like 4.5 meter by 3.5 meter. And now, what is the bonded rigid pavement? What we are doing is that instead of the DLC and GSB, is the DLC, GSB, and subgrade is considered as the foundation for a conventional rigid pavement. But for a bonded rigid pavement, GSB and subgrade are considered as the foundation. And because PQC and DLC they are mechanically bonded to behave monolithically, so we can economize on the PQC thickness by 60 mm. It depends on design. It could be 60 mm, 70 mm, 80 mm, but I mean, but is it the equivalent? I mean, what I mean, this saves. It's not that necessarily it gives an economical pavement design, but it definitely saves, gives us the cost of the cement and all. So preparation of the GSB bed, this is the methodology. Then, I mean, but because the methodology of construction of bonded rigid pavement is most important. And after the preparation of the GSB,
Your voice is breaking. I mean, it's not continuous.
it is laying of the DLC, and then we have because the PQC has to come in the DLC, which is not the case. The internet is a little bit of unstable. Sir, is it okay now?
It's
There's a breakage. Yeah,
Yeah.
it's okay.
Yeah, I mean, then we do the joint cutting and sealing in the DLC, which is not there in the case of the conventional pavement. Then the laying of the PQC, and then in the PQC, we map the joints exactly in the same location where we have cut the joints in the DLC. This is very important. Otherwise, bonded rigid pavement won't be a success. Now, these are some of the constructed the pictures. I mean, we can see, we cannot make out from the core which one is M15 grade of concrete and which one is M40 grade of concrete. If the bonding is good, you cannot even make out. And coming to the short panel concrete pavement, I mean, here you can, again, I won't say that you can economize, but again, there will be a saving in terms of environment, because the M40 PQC will come as 260 mm and the panel sizes will be 1 meter by 1 meter. What are the advantages? No need for dowel or tie bars, only required at expansion on construction joints, easy maintenance, less thickness. But the only disadvantage, I would say, that if you would need during the day, if you lay 300 of short panel concrete pavement, then joint cutting machines have to be doubled. If you were needing like 5 cutting machines, you would need now 10 cutting machines to do the timely joint cutting because of the 1 meter by 1 meter. But again, steel is saved here. So this is the short panel concrete pavement. Now, in coming to the thin concrete overlays for flexible and rigid pavement, we have white topping, and we can construct thin concrete overlay both on flexible pavements also and rigid pavements also. In some of the RFPs now, it is coming with white topping because, I mean, in terms of rehabilitation pavement, this is what is coming as given in the RFPs. And we haven't constructed yet, but this is very much prominent in in Maharashtra and all in Bangalore. It has been constructed. Now, these are some snapshots of unbonded overlay over existing concrete pavement with fabric interlayer. Now, coming to two-lift concrete pavement also, it is an Indian approach under development, where top lift will be with exposed aggregate and bottom lift will be with recycled aggregate. It hasn't been constructed in India yet, but I mean, the codes are in preparation, and soon we will have this type of pavements in India. And two-lift concrete pavement to maximize the use of recycled material, as I said, I mean, we are doing with the high dosage wrap in DBM. So we are thinking into use materials in concrete pavement as well. Now, precast concrete pavement technology. Again, this is an expensive thing, but in built-up areas, some areas in Nagpur and all, it has been constructed. I mean, the precast concrete pavement, but it needs precision work, and because of maintaining the camber and all, it requires precision work. We are still thinking whether to engage the precast concrete pavement somewhere or not. And now, accelerated the maintenance and rehabilitation technologies, it is being used in the international, the experiences are there. I mean, where repairs are there, we can go for these precast pre-stressed concrete pavements. And so that's all. Hope I maintain the time. That's all from my side.
Thank you, Atasi. I think you have shared a wide variety of new materials and technologies that are used. Perhaps I would have expected your sharing of experiences of the perpetual pavement constructed by GR and the issues and challenges. That is what we are looking forward. Anyhow, he has shared a wide variety of materials and technology that can be adopted. However, the issues of maintenance, preservation, management, lifecycle cost for all the technologies will be a real challenge. Let us hear from Nikhil. What are the issues in the design of a perpetual pavement, especially with respect to the engineered mixes? How do we go about? How do you predict the performance? What should be the endurance limits for these mixes? I think we'll hear. I think meanwhile, I also request the participants to kindly type your questions so that it will enable us to discuss at the end, so that we can get a feedback from the speakers on the question that you pose. Over to you, Nikhil.
Okay, thank you, sir. Am I audible?
Yeah.
Yes, you are.
Okay, so I'm just sharing my presentation. Sir, is the presentation visible in the full screen mode?
Yeah, it's good. Go ahead.
Okay, okay. So, good evening, everyone. Thanks to Professor Veera Raghavan for the introduction and moderating this session. Well, it is a pleasure to be a part of the 6th webinar on New Age and Perpetual Pavement for Performance and Economy, organized by IRF India chapter. I thank the organizing committee of IRF as well as Professor Sikdar for the invitation. Well, as is shown, the topic of my presentation is the use of perpetual pavement as a sustainable strategy. Though the concept of perpetual pavement is not new, if we see the global literature, its importance and use have gained popularity only recently in India. The purpose of this presentation is to throw light on the fundamental concepts underlying the definition of perpetuality. Data from some recent field observations in India will be shown, and I will try to clarify few misconceptions based on my limited understanding related to its design. Well, let us first recall the basic definition of perpetual pavement. Professor Veeraraghavan already defined it in the beginning. In very simple terms, a perpetual pavement is a pavement which will have a design life of more than 50 years. Now, what does this mean? It essentially means that the choice of pavement crust should be such that it can take significant amount of traffic repetitions before showing distresses beyond critical limits. Now, such pavements ideally should require only minor maintenance activities in the top few inches of the wearing course during the entire in-service life of the pavement. Some other terminologies, if we look at the literature, some other terminologies used for perpetual pavement are full depth pavement, deep strength pavement. And it is interesting to note that the conceptualization of perpetual pavement started as empirical experiments. The endurance limit which we talk about today were not established during the first construction of perpetual pavement. Now, those pavements which were designed for 20-year life, researchers observed that these pavements started giving performance beyond its expected life. That initiated the research to develop design methodologies for perpetual pavement. Typically, a perpetual pavement will have a wear resistance and renewable top layer. It will have a rut resistant intermediate layer and fatigue resistance base bituminous layer. This means that we will have 3 bituminous layers sitting at the top of either only subgrade or some minimum depth of granular layers. It should be noted that the role of granular layer here primarily is to facilitate drainage. Its engagement in the structural capacity is minimal. Now, as you see here in this picture, there is two comparison between the conventional pavement on the right hand side and the perpetual pavement on the left hand side. So as it is shown, the total thickness of bituminous layer in a perpetual pavement is typically more than 350 mm in most of the cases. Literature review indicates obviously variability in the thicknesses, but what we have observed that it is always more than 250 mm in general. I will show you it in the next slide. Now, the decision on the thickness of bituminous layer, at what should be the thickness 250, 300, 350, it is taken based on the limiting strain value at the bottom of the bituminous layer. Now, obviously, as you can see that since the crust of a perpetual pavement has a very thick bituminous layer, its initial cost is much higher than the cost of a conventional flexible pavement. Almost double for the construction of bituminous layer, in fact. But if you consider the life cycle cost, as is again shown from one of the literature, the cost of perpetual pavement is lower than the conventional pavement, considering the life cycle cost. Now, for HAM projects, that can be a good news, as the contractor is responsible for maintaining the pavement for almost 15 to 20 years. However, it should be noted here that it is assumed that the perpetual pavement will require lower maintenance cycle than the conventional pavement. So when we are doing the calculation for life cycle cost, this is an assumption. In case a perpetual pavement shows premature failure, it is not possible to extract the benefit of this overall cost reduction through the construction of perpetual pavement. Now, some general facts related to the conventional perpetual pavement. I say conventional perpetual pavement based on the literature review are as follows. So if you look at the binder, typically polymer modified binder has been used in the wearing course. For example, in India, in the perpetual pavement, we prefer to use stone mastric asphalt, which is produced using polymer modified bitumen as per IRC SP 79. The thickness design is based on critical tensile strain at the bottom of bituminous layer. While globally 70 microstrain is recommended, as per IRC 37, we use 80 microstrain, considering that our average pavement temperature in India is 35 degrees Celsius, higher than the average temperature used globally, obviously due to tropical climatic condition. The vertical compressive strain at the top of subgrade is limited to 200 microstrain, which is similar to international practices. Now, as I mentioned previously, the thickness of bituminous layer varies from 250 mm to 500 mm. And the average thickness of the granular layer is limited to only 175 mm because it is primarily acting as a drainage layer. Okay, but it is not a mandatory requirement, obviously. So now I will walk you through two conditions as per Indian practices. So we will talk about two choices of perpetual pavement, conventional perpetual pavement and one with cement treated bases, which Ms. Atashi Das already showed. Now in the conventional approach, we consider that the main structural element in the entire pavement cross section is the thick set of bituminous layers. There are three set of bituminous layers here. Granular layer, as I said, is provided mostly for drainage. Now, for such structure, the endurance limit have been tested by various researchers globally, and there is a general consensus on the limiting values, which are 80 microstrain or 70 microstrain and 200 microstrain. There is no doubt that the entire structure can be called perpetual. This is important. So we have to remember that the definition of perpetuality is related to the structure of the pavement, not just the bituminous layer. We have, if you see IRC 37, we have two performance models which can be used in conjunction with IIT PAVE to estimate the crust thickness by ensuring that the actual strain below the bituminous layer and at the top of the subgrade is less than the critical values. So it can be easily done. So ideally, by definition, this pavement should never fail structurally. This is our assumption. However, we have seen failures in the conventional perpetual pavement also. I will show you some of the pictures in the upcoming slides. In fact, forensic investigation worldwide has also shown that perpetual pavement sometimes can show premature distresses. So what are the form of these distresses in the conventional perpetual pavement? It can be in the form of rutting in the top bearing course. This can be in the form of either shear failure or top-down cracking, not bottom-up cracking. If the compaction of the top layers are not appropriate, which is one of the reasons our Indian perpetual pavement has failed in the recent past, water can infiltrate, it can get trapped within the bituminous layer or at the interfaces of the bituminous layers, which can lead to generation of poor water pressure and very high shear stresses at the interface, leading to the premature failure. So we have to be careful about these aspects. However, in India, unfortunately, we do not account for these variables in our design. Shear failure, we do not account for bituminous mixes. We do not account for top-down cracking. We just have a criteria of using, incorporating this aspect in the mix design. Moisture-related failure in one or more layers is not accounted for. And of course, construction-related failure is also not accounted for in the design. But these can happen at the site. Now let us talk about the design of perpetual pavement using cement treated base. So as Ms. Atashi pointed out, that for contractors, that can be a very catchy option because the cost reduces, thickness reduces. So what contractors have been doing and how they have been designing, let us look into that. Now here, the resilient modulus of the CTB is taken as 5000 MPa, which is much higher than the stiffness of bituminous layer, which is in the range of 1500 to 3000 MPa. Now such pavements where a stiff layer is sandwiched between two relatively stiff, less stiff layers is called as inverted pavement in the literature. Now such pavement, what does it do? What does inverted pavement comprise of or are made for? Such pavements, it tend to reduce the strain below the bituminous layer. So you just imagine that when a load is applied, the CTB being very stiff gives an equally opposite reactive force. We have to imagine this. This makes the top bituminous layer under compression and the bottom bituminous layer experiences compressive strain instead of tensile strain. Therefore, the ideal load carrying mechanism of a flexible pavement is not applicable here, which means that the load is not transferred from grain to grain as we typically assume in a conventional flexible pavement. Now, if we look at the critical points of analysis as is shown in this figure, in addition to the bottom of the bituminous layer and the top of the subgrade, we have another critical point at the bottom of the cement treated base. But the endurance limit of such pavement is not known so far. We know the endurance limit of bituminous layer, we agree to that. We know the endurance limit at the top of subgrade, we agree to that, but we do not know the endurance limit of a cement-treated base layer so far, even in the literature. Therefore, just using the axle load spectrum, assuming a hypothetical traffic growth rate, as was also pointed out by Professor Veeraraghavan, and designing for 50 years can be misleading in this case. Additionally, such pavement also requires very high quality control in the construction, especially related to procuring, amount of cement we add, and so on. So we need to be more careful here. Okay, so if we look at the equations again as per IRC 37, in addition to the fatigue and rutting equation, we have two equations for cement treated bases. Now I will just point out here the third equation. If you look in the third equation, we make a check to the tensile strain at the bottom of CTB. This is not the endurance limit. This equation, which has been taken from foreign guidelines, is not based on endurance limit equation. So the consideration of infinite fatigue life of the entire pavement structure is not applicable here, and it cannot be designed as a perpetual pavement. This is what I believe. So earlier pavement, so let us say a cement treated perpetual pavement shows failure. So can we say that this pavement has failed because of the presence of cement treated base? Well, maybe yes, but maybe no. Depends on how the failure has actually occurred. So we have to do a thorough forensic investigation for the same. Now I have taken a very good example from an actual report. Details have been excluded. So this perpetual pavement was designed for 300 MSA. I have seen this report. I have seen the entire calculation. So the contractor proposed use a bituminous layer of 175 mm, aggregate interlayer of 100 mm, CTB of 200 mm, CTSB of 200 mm, and the subgrade CBR was 12% in the design. I have checked the axle load spectrum data. I have checked the analysis. Horizontal tensile strain below the bituminous layer to be limited to 80 microns. It was valid here. Vertical compressive strain at the top of subgrade 200 microns. It was correct. Horizontal strain at the bottom of CTB to be limited to 60 microns based on the third equation, though that is not a perpetual value, but yes, it was valid as per IRC 37. Cumulative fatigue damage to be less than 1. Yes, it was valid. So all the checks were satisfied and the crust was considered as perpetual as per IRC 37. So there is no discrepancy in the design and the design is correct. But the important question which we have to ask here, do we call this structure to be truly perpetual without the availability of data related to the endurance limit of CTB layer? Now, the same problem, if you try to explore other option, you can design the pavement in various ways. In fact, I could have designed the pavement with lower thickness than what contractor provided. So I could have reduced the thickness to further only 150 mm of bituminous layer. Still, the pavement will be safe in this case. However, the question here is, do we really call this pavement perpetual? Because as per data available, the minimum thickness of bituminous layer in almost all the perpetual pavement used worldwide has been at least 250 mm, which they have not provided. Now, I will show you some of the recent work. So if you see the recent 3 expressways we have constructed in India with perpetual pavement, we had Delhi Vadodara, which was constructed using a conventional approach, Delhi Amritsar Katra, again conventional approach, and Bangalore Chennai with cement treated base. Now, all these pavement have shown premature failure in different packages. So let us see some pictures. So no traffic has moved on the pavement, no significant traffic. Premature failure, you can see rutted pavement on the wheel path and how the moisture has accumulated. Same picture from the site. You can see another type of distress occurring in the field, premature. You can see another distress occurring in the field, premature. Pavement has failed, being perpetual. If you see, patching work has been done, though the patching period should not have come so early here. Again, you can see some patching being done and distresses on the pavement. You can see further distresses on this pavement. These are different packages, different expressways constructed using the concept of perpetual pavement. There is a short video taken through a windshield survey. So you can see that how the pavement has drastically failed before even significant amount of traffic has moved on the pavement. some patching work being done. You can see segregation on the pavement, more patching work being done. You can see cracks being filled, that too at a very, very early stage. So these are all failures. Now, why this pavement has failed? That is the question we have to answer. And why being designed as a perpetual pavement, being designed as a constructed as a perpetual pavement, why they have shown premature failure? In one of the discussion, we argued that probably the design was not correct. But the question is, even if the design is not correct, let us say even if we have a 100 mm bituminous layer, it should not have shown premature damages so early in the pavement before even the traffic has started to move. So recently what we have observed that there is a lacuna of technical know-how in the country. We are adopting all the best practices, no doubt about that. We are ready to implement that, no doubt about that. But the question is, do we really understand the difference in technologies? Let us say SMA. Ms. Atashi Das pointed out that SMA is a very special mix. Indeed, it is a special mix. We have seen that contractors are not aware about SMA's technical know-how. They use polymer modified bitumen in SMA. They do not know at what temperature the mixes should be produced from the plant, at what temperature they should be compacted. They believe that stone mastric asphalt or bituminous concrete mixtures using PMB can be compacted at 130 to 140, which is wrong. You cannot compact a polymer modified bitumen. These days, suppliers are using high dosage of polymers, 3 to 5%, sometimes more than 5%, to satisfy the requirement as per IRC SP 53, as per IS 15462. But the mixing and compaction temperature is something that no one is paying attention to. We have done several studies in the laboratory. We have seen in the field that the lag time between mixing and compaction for PMB is very, very short. If you are producing the PMB in the plant at 160 to 170, it should be compacted higher than 140 degrees Celsius. If you go below 140 degrees Celsius, you will end up having a SMA mix with high air void content, as high as 10%. Now, if your air void after placement is as high as 10%, this pavement can never sustain, because just after monsoon, water will penetrate vertically. It will first damage the inherent bituminous layer, then it will go to the interface. Once it damages the interface, then the entire slipping of the top layer will start as soon as traffic starts to move over it. So the quality of aggregate in SMA, quality of lime, again, no one is paying attention to this aspect. And most importantly, mixing compaction temperature and the procedure of compaction. So I'm very happy that now in the coming years, MORTH has recommended that the breakdown rolling should be done using a vibratory roller. That is a good approach. But for SMA, the sequence of compaction is very, very different than the sequence of compaction in a conventional bituminous layer. We have to pay attention during construction. As I said, if the compaction temperature is low, this will result in very high air void. This will weaken the interface, and such pavement can fail without the movement of significant traffic. Interlayer between the asphalt layer, inadequate use of tack coat and quality of tack coat is important. This is more important when you have a bituminous layer over cement treated bases. Now, if you see the surface finish of a cement treated base, it is a smooth finish, unlike a WMM, which is a rough finish. So if you are placing a very thin microns of bituminous layer and you are expecting that it will bond with the top bituminous layer, it is really doubtful. So further researchers in India are required to adopt best practices for interlayer mechanism in different kind of composite pavement, especially when you have a smooth base layer and you have a bituminous layer coming on the top. Again, cement treated base and bituminous layers, they are thermodynamically different from each other. When temperature changes, their change in the dimension of these mixes are very, very different. So there is a high chance that the interlayer will weaken over a period of time. We have to pay attention to the type of interlayer material being used. Probably a thick layer of polymer modified bitumen can be a better solution for the interlayer, especially when you have cement treated bases and bituminous layer on the top of that. So this is what I have listed out, some of the lacuna in understanding and what we should pay attention. And I'm sure that if small things can be controlled, all these technologies can be successful, definitely. Another important aspect which we have observed in the recent times, especially in expressways with high embankment construction. So due to the speed of construction these days, no one is paying attention to the consolidation in the subgrade soil. So if you have not compacted the subgrade soil properties properly, especially in case of high embankment, and there is a secondary compaction happening at a later time, the entire pavement can settle down. So we have to be careful about the same. Okay. So in summary, perpetual pavement is a relatively new concept in India. So let us use the available experience. Let us monitor the constructed pavements with time, including pavement using cement-treated bases. Performance data is something which will help us in further decision making. Since the endurance limit of long life flexible pavement with cement-treated bases is not known, Ministry has given a project, multi-institutional project now, where we are investigating the endurance limit of cement-treated bases. Till then, it is just a recommendation that it should not be used for greater than 300 MSA traffic in the name of perpetuality. There should be a criteria which I strongly believe related to the minimum depth of bituminous layer. So the contract document, the DPR should specifically mention that what should be the minimum depth of bituminous layer in case of perpetual pavement. And it should be limited at least to 250 mm. Construction process and, as I said, use of appropriate interlayer bonding is very, very crucial when you have multiple layers of different types of bituminous mixtures which are very different from each other mechanically, as well as the response to loading is very different. Perpetual pavement can be sustainable only when we design and construct it with high quality control. This is the final statement from my side. With this, I would like to end the presentation. Thank you, sir.
Nikhil, let the last slide remain.
Okay, I will share it again, sir. Okay, sir, are you able to see this slide?
Yeah, exactly. Yeah, this is what needs discussion at this point of time.
Okay.
Where are we now? I think last slide, next slide. Thank you slide only I wanted.
Oh, thank you slide. Okay, sir.
Yeah, right, yeah.
Right, okay,
This is
sir. I understand now.
Yeah, exactly. So what we need is that where are we now in the Indian scenario? Are we crawling? Are we trying to get up and stand? Are we able to walk? Or are we trying to run before we could crawl, stand, sit, stand, walk, and are we trying to run? This is a question that needs to be answered at the end of this presentation after discussions. Let us discuss about this further. Thank you, Nikhil, for
Thank
that talk. Yeah. There are a few questions that are posed on the question and answer. I also request other participants to kindly type the questions so that we can take up the questions one after another so that we can have a meaningful discussion. Sachin has asked the question, what shall be the minimum and maximum design traffic? I think you have also mentioned about 300 MSA. Can it be 500, 700, 1000 MSA? What should be the design traffic that should be considered for the design of a perpetual pavement? Can we have a specific binder mix specifications for a rut resisting mix, crack resisting mix, or will a balanced mix design address these two? I think, Nikhil, could you please answer this?
Yes, sir. Okay, so thank you, Sachin, for the question. Well, sir, recently we have seen in one of the projects where this issue arose regarding the choice of the type of pavement to be used depending on the traffic criteria. So what I believe that what literature mentions that beyond 300 MSA, we can use perpetual pavement irrespective of the traffic. Theoretically, it is correct. But what we should see is the variation in the Excel load spectrum data. Recently, I have seen one of the Excel load spectrum data where the average VDF was around 50. The maximum VDF was 135 and the minimum VDF was around 0.5. So there, if you see the coefficient of variation of the VDF, this is very, very huge. So in such cases, considering 35 as the average VDF may not be the true representation of the actual traffic which is coming on the pavement. For such pavement, probably contractors should have multiple options. Let us say we can have a perpetual pavement and we can have a concrete pavement. Let us do a cost estimation, because the benefit in concrete pavement related to the analysis is that the axle load spectrum data can take account for even the heaviest vehicle, because the stress ratio component can be calculated, and even the average load of the vehicle, because we are calculating the stress ratio, and CFD is being used. So if the traffic variation is very, very huge in some of the locations and it is beyond 300 MSA, I think we have to work out options between perpetual pavement and concrete pavement, and let us choose the cost-effective option. So this is my answer to the first part, sir. Sir, you are muted.
About the mixes, she asked the second question about the mixes. What should be the type of binder and mix specification for a rut resisting upper binder course, the bottom fatigue resisting lower binder course, as well as the wearing course? Can we have 3 different mixes for these 3?
Sir, we can have, because international literatures also have used 3 different mixes, but we have to be, as I said, we have to be careful about the interface. Usually in the top layer, most of the agencies worldwide, they always use polymer modified bitumen. So I think stone mastic asphalt is a good choice for the wearing course. For the intermediate course and the binder course, I would like to prefer DBM2 over DBM1. DBM1 relatively has bigger pockets of voids. By any chance, if water percolates vertically, it gets trapped in those voids, then again you will see interface failure in this pavement.
Thank you, Nikhil. I think that has been brought out. I think I wanted to ask Atasi also about the same question about the DBM grade 1 of 37.5 with a thickness of 75 millimeter does not meet the requirement of the nominal maximum aggregate size layer thickness. In fact, it has been proposed in the next revision of the ministry to delete the 37.5 and consider 26.5 as a DBM1. Yes. So don't say DBM1, it may be misleading. Say DBM1 of 37.5 or 26.5. In future, if the ministry accepts, correct, then 26.5 will become the DBM grade 1. DBM1. Okay, we will discuss further. I think that Mr. Atasi, Akash has asked a question about the flexible overlay as a structural layer on a concrete pavement. The draft is under process. I think you can share some thoughts about what we are doing on the bituminous overlay over a concrete pavement. Atasi? Atasi is not there. She's muted.
Yeah, she's registered, but muted.
Atasi? Once Atasi is back, we can talk. But anyhow, I will share that there are issues and concerns with respect to the construction of a bituminous overlay over a concrete pavement. A distressed concrete pavement has to be overlaid with a bituminous overlay. There are issues with respect to the load transfer between the concrete pavement to the bituminous. There is the need for a geosynthetic interlayer. So we are working on that. Atasi has already prepared a draft code on a bituminous overlay over a concrete pavement. If it is approved, perhaps this year, we can have a new code as how to construct a bituminous overlay over a concrete pavement. Chirag has asked a question, what should be the feasible length of flexible overlay on a rigid pavement? I think Atasi, when she joins back, we can ask this question. Again, Chirag has asked the second question on the same bonded and unbonded overlays. I think, again, we have to wait for Atasi to join. Gaurav Kumar has asked a question, CTB and CTB-SB modulus decay time by time is sufficient to fix a high modulus value for CTB and CTSB, or we can increase it and take a higher value more than 5,000 and 6,000 MPa, CTSB. I think, Gaurav, you have to remember that all these concrete layers with a lower cement content will eventually crack. You can have 8,000, 9,000, 10,000 also you can consider. But how will it perform? I have seen several thousand kilometers of roads in China where they have cracked transversely. So all these layers, cement-treated layers, are likely to crack. We should expect that. That's what Nikhil also had mentioned, to provide a polymer modified binder as a tack coat and the appropriate type of geosynthetic. And Nikhil, could you please tell what should be the CTB and CTSB moduli that they should consider?
Sir, yes, sir. As you mentioned, when IRC 37 was being developed, the lab data showed that CTB and CTSB ideally in the initial stage has high modulus, but considering that they will eventually crack because construction traffic will move, there will be shrinkage in the materials. So a conservative value of 5000 MPa and 600 MPa was opted for. So this was the only reason for considering lower values than the actual values that were being measured in the initial stage in the laboratory.
Nikhil, there's one more question I think that is not being addressed. Sachin has asked the question. For many of the roads that have been, I have also investigated several failures. The failures are due to the lower layers, either in terms of inadequate compaction of the subgrade, subbase, or the base layers, or inadequate subsurface drainage. So in the concept of perpetual payment, how do you ensure that such failures do not occur? What precautions should be taken?
Sir, I think for the lower layers, if you start from the subgrade, you have to monitor the compaction very closely, and you have to achieve at least the minimum density which is required as per ministry specification. But the recent failures which we have seen in perpetual pavement, I believe they are mostly because of the top layers not compacted well. Because the top layers comprises of polymer modified bitumen. In many a case, it was reported that the compaction temperature was around 130 to 140 degrees Celsius. And they have not used, I think one of the question also asked related to the compaction pattern, they have not used vibratory compaction initially at the breakdown rolling. So we have to remember this polymer modified bitumen has very high elasticity. If you compact, when the mix is hot, that is the best time to vertically compact it so that you can achieve the maximum density in the first pass. So vibratory roller is must as the breakdown rolling. And we have to also remember, which we have to monitor also, that there will be an inherent rebound of the mix once the roller passes away. So the passage of the roller, the timing between the passage has to be monitored very closely. And we have to compact the mix before the matte temperature falls down below 130 degrees Celsius max.
Yeah. Thank you, Nikhil. That's a very valid point. In fact, this is also been introduced in the next revision of the ministry, wherein it has been included that the initial breakdown rolling should be by the vibratory roller when the mix is hot. Yes. I do hope that ministry will accept that suggestion. There's a question by Kiran. What should be the role of VA and VB in the case of perpetual payment?
Well, the role of VA and VB is mostly related to the fatigue equation which we are considering. If you see the previous IRC specifications, they did not use the volumetric parameters as one of the input in the design of pavement. But recently it was introduced considering that if the lower layers can be compacted at lower air void content, typically, let us say we are using 6 to 8% infield air voids. So if we can compact it to 3 to 5%, which means we are increasing the binder content, that will provide more flexibility to the mix. So that will, sir, vary from mix to mix, the value of VA and VB. But these values are standardly adopted as per IRC 37 2018.
Thank you, Nikhil. I think Chetana has posed a question about the maintenance activities. Chetana, what we recommend in the case of perpetual payment is that the distresses will be confined only to the top layer, maybe in the form of raveling, maybe minor top-down cracking, or can be some other distresses like patching potholes, maybe due to the variation in the constraint quality. So the maintenance required for this will be only patching, maybe that some preventive maintenance that is adequate. No structural overlay will be required for perpetual payment. There's an anonymous attendee who is asking, can we use a modified binder other than PMB? Yes, we are not specifying that PMB should be used. Any binder can be used so long as it meets the criteria of retting and cracking. Ujjwal Solanki has asked, what should be the rolling pattern when using the PMB? Nikhil, can you say something?
Yeah, so, sir, I think the first breakdown rolling, as you mentioned, is the vibratory rolling. The second pass for SMA, it can vary. So we can use a plain pass roller and then we can surface finish the pavement. I think pneumatic tire rollers are typically not used in case of stone mastic asphalt.
There's a question. I think, I don't know, Atasi, are you able to join? There are a few questions which
Yes,
yeah.
sir. Yes, sir. Yes, sir.
Yeah,
Am
fine.
I audible,
Yeah.
sir? Yes, sir.
Yeah, fine. Yeah. The question from Sanjay Sharma is that, is there any example of thin white topping or flexible pavement in India? If yes, what is the PQC thickness used and what intensity of traffic?
Sir, there are many examples. As I said, in Maharashtra and Bangalore, many examples are there of thin white topping, and these are done for the city roads. So for city roads, it is like a different kind of traffic pattern completely. So for the sustainability, there are many debates going on, but the thing is that it is getting constructed. Thin white topping, ultra thin white topping, these are getting constructed all over India. I don't have experience yet, means we haven't constructed yet, because it is done majorly for the city roads. For highways, we are yet to construct, and many RFPs are coming with it. So maybe we will construct soon. So no experience as of yet for me.
Thank you. Yeah, I think to answer that question, I think you should visit the Nandi Highway, a peripheral road around Bangalore. It was
Yes, sir.
constructed with the thin white topping, weighing 180 millimeter. It carries more
Yes,
than
sir.
3,000 to 4,000 commercial vehicles per day. It's more than 8 to 10 years by now. The performance is excellent. So we
Yes,
have
sir.
experiences of constructing thin white topping over a bituminous pavement.
Yes,
There is other questions with respect to the overloading. I think you also mentioned, Nikhil also had mentioned, is there a way to incorporate axle load spectrum, high VDF in the design of pavement? I think that is being considered. But in case of very high overloading, which is very rare, how do you address this in the pavement design?
Sir, very high overloading we are unable to address in pavement design currently, because one of the projects I'm now working with Professor Nikhil only, and we are confused. I mean, we can propose like MSA wise, it is coming more than 300 MSA, but again, I mean, we are unable to capture the VDF in flexible pavement design, but we can capture that kind of loading in like axle load spectrum. Say if we are designing as a rigid pavement, that kind of axle load spectrum can be designed for in rigid pavement. But right now we don't have any parameter where we can address this high overloading, because say, sir, if there are even like per day 10 movements of these vehicles can do the channel type of rutting in the flexible pavement. But I mean, when we do the average VDF, these VDFs are coming to the tune of 25 and 30, which again doesn't take care of the movement of say 10 movements per day. So since these 10 movements per day are not captured in pavement design, we are unable to capture in pavement design, but definitely we can address through the rigid pavement.
Yeah. Chetra, you had asked a question about the high VDF. I think high VDF is the problem faced. That's what has been mentioned by Atasi. It has been considered in the design stage, but nevertheless, there's a wide variation between what we design based on the estimated traffic and what is actually plying. Therefore, a pavement will warrant early maintenance. That will be the issue. There's a question about the rigid bond pavement, as mentioned in IRC and MORTH. To answer this question, we are coming out a new code on a bonded pavement. I think maybe in the coming IRC, a new code may be released, or in the forthcoming sessions of the IRC, a new code on a
this will
bonded
be
pavement.
released. This will be released in November.
Yeah, right.
Yes, sir.
So that's a question. In the case of CTB and CTSB, when the cement content increases, is there any issue becoming the pavement as rigid and may form a crack in the future? Exactly. Higher cement content, if you have, it will definitely crack. That is why we always recommend a crack retarding layer whenever you construct an overlay, bituminous overlay over a concrete pavement. Anurag has a question to Nikhil. Can we include pavement with a reinforced granular layer as an option for perpetual pavement?
Well, sir, I have my own reservations related to the reinforcement of granular layer, especially in perpetual pavement. So what happens, if you look at the design, obviously any contracting firm will try to design at the least cost. So let us say why they are using reinforced layer. They are using geosynthetic layers so that they can use the value of modulus improvement factor, increase the modulus of the granular layer, and have lower thickness of the bituminous layer. That is the idea here. But what we have observed, especially in case of perpetual pavement, you have a very thick bituminous layer sitting at the top. and let us say you have a granular layer reinforced with geosynthetic. If you apply even 40 kilonewton of load, 80 kilonewton of load, 100 kilonewton of load, that load, the stresses developed because of that load is not sufficient to mobilize the geogrid. If the geogrid is not mobilized, most of the load is being taken by the top bituminous layer. It is not transferred to the granular layer. In that case, the bituminous layer will be distressed beyond what we are expecting. So especially in special pavements like perpetual pavement, my recommendation is until and unless we have enough performance data, at least from India or international literature, we should not try many new things at this stage because we have just started using perpetual pavement. So let us use the international experience, construct conventional perpetual pavement with best construction practices, monitor its performance. We can have few sections of some innovative type of structure, which we call as perpetual. We can parallelly monitor their performance, and probably down the line in the next 4 to 5 years, we can have good idea on which pavements are performing well. Then only we can have an answer for this question.
Yeah. Thank you, Nikhil. There's one more question about the rolling pattern in SMA.
Sir, I think I answered that question.
Yeah, okay. From Anurag Mishra, there's a question to Atasi. Can we replace the existing conventional rigid pavement with a short panel concrete?
Yes, sir, definitely. Because one of our pavements where we have very heavy traffic, like quarry traffic, where the conventional PQC pavement is like 310 mm, and we have constructed, and the same project we have constructed short panel concrete pavement also with 260 mm thickness, and it is doing very well. I mean, it is 1 meter by 1 meter, no dowel bar, no tie bar, and it is doing very well. So we can replace very, conveniently the conventional rigid pavement with short panel concrete pavement.
Yeah, there's a question again from KK Ghosh. How to reduce the consolidation settlement in a high embankment expressway? I think Nikhil also had shared the same thoughts. What are your suggestions for that?
Sir, I was talking about monitoring the density of different layers, but I think you have to answer this question, sir.
Atasi has done a lot of work on this high embankment. That's why I was particular to Atasi to answer this question.
Sir, high embankment construction is like, it is related to the time of construction given. Like we are asked to construct our high embankment in 18 months. And when we are constructing in 18 months, of course, I mean, site people will say that we are laying like 250 mm, 200 mm layers, but actually they are laying 1 meter layers. And I mean, it is site monitoring and quality, like, and monitoring with using the NDG unit and all, because this is a hassle also. When we are having 7 meter high embankment, every monitoring with for every 250 mm with the conventional technique of compaction checking, it doesn't hold good. And I would say the use of advanced equipment for compaction purposes, and use like intelligent compaction units where we get a real real life, like from the equipment only we get the compaction technique and how much compaction is achieved, and use of advanced equipment and use of GPS and all unit, and use of the monitoring technique within the equipment, we can improve. Otherwise, there is no way that we can go for fast construction and quality construction.
Okay,
there are lots of equipments there. Yes, sir.
Yeah, fine. There's a question again about is presumed the structural overlay may not be required, but roughness correction course is required. Yes, exactly. Can we use microsurfacing? Yes, you can use microsurfacing. You can have thin overlays. In fact, the new code we are proposing a 30 millimeter BC as well. Perhaps you can use that also to improve the rating quality. Gaurav Kumar has asked a question. We have two criteria. One is MSA, other is strain. MSA criteria is satisfied, which means result is greater than 300 MSA, but strain and stress criteria is not satisfied. In such situation, what should we do? Nikhil?
I sir, probably did not understand this question. I will read it again once. I'm trying to search for the question.
Gaurav Kumar, 843.
Okay, so the road is 90 and the, okay, not this.
843.
I
think your time may be different, right? Yes, time.
I am, sir, trying to. Sir, I have
Yeah,
seen
right.
a question that the road
The
design
question is that if MSA criteria is satisfied, that means traffic is more than 3, result is greater than 300 MSA, strain is not satisfied. If that is the case, you redesign. Simple.
Yes.
Simple.
Yes.
Sachin has said that the payment is designed for CTB, but was not the same insight. That's what that I have mentioned that in the beginning also. Quality matters.
Yes.
You have 300 MPA, 5000 MPA, 700 MPA, all on paper. Issue is that where are we getting this number in the field? That's why exactly the Ministry of Rural Development, NRIDA, has sanctioned a project so that we learn from the field, are we getting? Based on the earlier experiences of performance monitoring of concrete pavement in rural roads, we found the quality of the concrete as constructed is not as per the design. So therefore, quality will matter. There is no compromise on the quality. It relates to the performance. The other question is how to calculate the cement content in CTB if the sample has been taken for the site. I think there is no method by which you can consider the estimate the cement content. How to check the design procedure field density? I think we can check the density of the cube or the cylinder, but I do not know. Is there any way to check the cement content at ASI? I am not aware.
Sir, no, I mean, we can, I mean, during laying only we can check. I mean,
Yeah.
from the number of bags and all what went in.
Yeah.
Otherwise, after laying, it is difficult. Yeah.
Thank you. I think that's another question, Nikhil. Is agricultural waste in payment layer? I think Nikhil has been working on some aspects. We can throw some light.
So, well, we have been using on the development of biobitumen using agricultural waste, but the waste as an additive in any of the layers, I have not come across so far.
Okay. There's a question is about this at ATASI to match the joints of unbonded overlay with joints of existing PQC. How to match?
It is easily possible because I mean DLC has an offset, right? So in that offset portion, we mark it with red paint, and we have an 500 mm to 750 mm offset. So with red paint, we keep it marked, and after laying the PQC, it is like sooth patakna. We use the thread. And at those red mark on the red joint mark, we put on the PQC like as RK Jain sir says that sooth patakna in the laid freshly laid PQC. That's how we match the joints. It's like a jugaad type of technique only we are following, and it's written the same way in the code as well.
Nikhil, there's a question about this bottom ridge pavement. Will it create a problem when we add higher binder?
Yes, sir. Sir, I think this is an important question, what we have observed, what we have heard from contractors during execution also. So, sir, the problem is in India, what we typically do when we construct the DBM, after the construction of DBM, we leave it open to the traffic for a few months. Because the road is being constructed, the plant is operating for DBM, and until and unless they construct a significant amount of length, they do not start the plant for BC mixtures. So, BC is laid months after DBM is laid. In case of bottom reach DBM, definitely this is a good option. But if you leave it to the open traffic, the surface will appear to be bleeding, especially in summers. And it is possible that the tires of the vehicle will start picking up the bitumen slowly. So bottom ridge DBM is good if we can construct BC immediately before opening to traffic.
There's a question from Gaurav Kumar to ATASI about the diffraction cracking in CTB and CTSB. What are the quality control measures during construction which we can control this cracking? I don't think that's possible. Anyhow, ATASI, you can share your thoughts.
Sir, I mean, it's not possible. I mean, if it is during construction, and there will be construction traffic plying on top of it, we cannot control it. And as written in IRC 37 core is desirable, CTB cracking is desirable in CTSB, sorry, CTSB, not in CTB, of course.
So eventually these layers will become like a granular layer. That's why we recommend providing a crack retarding layer, either in terms of aggregate interlayer or a geosynthetic layer. There's a question about the frequency of periodic overlay requirement. This periodic overlay requirement depends upon the distresses, severity, and extent. Maybe the preventive maintenance may be adequate if the pavement is well designed. Nikhil, can we include the pavement with the reinforced granular? This question has been answered. Is there any procedure to optimize the crust using GeoGrid GeoCell? I think IRC SP 59 is there. This is by trial and error. You can try to work out. But again, the quality matters. The property of geosynthetic matters. So if everything is okay on paper, you can try to optimize. The question to Nikhil, a road design is 90 MSA, total crust thickness is 470, and the crust is better for 90 MSA. It's okay. It all depends upon what model A value you consider, and are you able to get that model A value in the field. If it is so, your design is okay. So I think that's a question. Perpetual payments, design only strains are being consulted. But again, these issues of VA, VB, shear failures are not addressed, moisture damage is not addressed, we accept that. Pavement crust design is for 20 years period, but failing in construction traffic, in such scenario, what should be the option to be explored to satisfy the design thickness? This crack layer is likely to crack. This is what Atasi has already mentioned. A CTSB layer, when it fails, it's okay. That's why we are taking a preventive maintenance or precautions by providing a crack retarding layer. Can we comment on the overall reduction in the life cycle cost? I think it's difficult to, at this point of time, to predict the life cycle cost because we do not know how this pavement is likely to perform. It has got different materials, different layers. Perhaps unless we have some performance data, we will not be able to authentically predict the life cycle cost. Is any procedure to optimize the crust using geosynthesis? This has been answered. FW analysis is feasible for the remaining life estimation. That is what we are trying to do in the FDR project of NRIDA. This is a question of Sachin Gowda. There's a question about the riding quality issues. Limiting values are as per the IRC SP 16. I think they are mentioning as SP 19, wherein they talk about the riding quality limits. Can we use CRMB in SMA design is another question. We are suggesting to use a polymer modified binder. You can try with a CRMB, depends on the quality.
So for CRMB, we have GGRB. We have a separate code, which is a gap graded mix, very similar to SMA, but the gradation is different. The same can be used with CRMB.
Okay. Can you use a slag aggregate in CTB and CTSB, Atasi?
Slag aggregate?
Yeah.
Well, it depends on the properties, sir. I mean, it will depend on the properties of the slag aggregate. It will be case by case basis.
The one last question is about the short panel concrete. Can we have a short panel concrete for thicknesses more than 200 millimeter?
Of course, sir. For short panel concrete, I mean, when we are designing using the new code that has come up with short panel concrete, then we can have thicknesses ranging from 180 mm to 270 mm. So no issue. I mean, it is as per design. Whatever it is, it will be as per design.
One last question is about this 403.2.6. The mixed design shall be done to achieve a strength of 1.75 MPa. Is it the minimum or the maximum? We are confused.
Sir, which layer is this?
This is a 904, an anonymous attendee.
Oh.
About the class 403.2.6. I don't know whether it is a CTB. I'm not very sure.
Okay, so if it is CTB, I think UCS should be the criteria.
Yeah. Mike has asked a question. Preventive maintenance measures if flexural strength of new rigid pavement come very low, but joint efficiency is found to be good. When the flexural strength is low, then I do not know. You can only talk about the load transfer efficiency. Chirag is to match the joints. Again, this question has been answered. What is the maximum MSA thin white topping serves as mentions the requirement of thin white topping or existing and it has been tried. I think you can check with the Nandi Highway what the traffic that they have predicted. It is performing well. The proof of the pudding is in the eating. I think we have come to the end of this questions that were posed. I think we are at 9 time up. So
I just want to answer because I just went through one question. I'm not finding that now from Dr. S.S. Puar. And it was a question on the riding quality on short panel concrete pavement, how to achieve that. So, but for short panel concrete pavement, the joints we are cutting is only 3 mm and only like 2.5 to 3 mm joint. The riding quality doesn't matter. I mean, the riding quality is not with that kind of joint spacing, joint width rather. I mean, the 3 mm, the riding quality is it's good. I mean, it doesn't matter.
Thank you, Atasi. I think we had a very useful and fruitful discussions. So you have presented about, as Atasi presented about the upgradation of payment technologies. Several technologies are there, starting from the subgrade, subbase, base, binder, wearing codes, as a drug resisting layer. A lot of research is in place, but still what is missing is the performance data. If we want to predict the life cycle cost, we need to predict as how these materials and technologies will perform or performing, duly accounting the construction quality. The other issues that are to be addressed are the modular values as constructed or as considered for the design. So unless we match the design values with what we get in the field, the payment cannot perform as you predict. There are many examples of the full depth reclamation that she has mentioned about the choices and options. The issue that need to be addressed are, as rightly asked by some few of the participants, about the lower layer compaction, stabilization of the subgrade layer, subbase, subsurface drainage, more importantly, all these are to be considered. These Indian mixes, are they adequate, or do we have to develop Indian mixes to which will meet the requirement of the performance is again an issue. Estimated traffic will be going to be a real challenge, the very high vehicle damage factor. You can use geosynthetics. I think Atasi can deliver a talk for a detailed lecture on the geosynthetics, failures, lessons learned, and what the way forward. That's a separate subject by itself. On paper, everything is work, but when we try to implement, because of wide variability in the material and construction quality, even though they're expected to perform, they have not been performing. Cocktail binder will be an issue in the case of wrap. In case of high wrap content, the wearing course will have a different binder. The upper binder course will have a different binder. Maybe that few overlays will have different binders. If so, how do you rejuvenate the old oxide binder and consider a new binder that is to be added? Is per dosage has to be studied. What we need from all the participants is that we look forward the feedback on the performance of the highways. If it has failed prematurely also, let us know so that let us not repeat the mistakes. I think the study should also extend to carbon credits. I think as rightly mentioned by Nikhil Sabu, the perpetual payment does not address the issues of shear failure, bonding, moisture issues, top-down tracking, as well as the quality-related specifications. As I mentioned, I think we are in the process of standing and walking before we could run. I think we should be stable before we can adopt perpetual payment in the Indian scenario. That is my thoughts. I think Professor Sikdar can share his views.
Thank you. Thank you, Professor Veera. It's fantastic. I mean, 150 captivated audience listen to the two giants of pavement engineering. And of course, the master of pavement engineering, the moderator. Well, this webinar has been wonderful, and I'm sure all the attendees must have learned a lot, gained some experience, what can work, what cannot work. And as the moderator has very clearly mentioned, where are we? Are we crawling, or are we standing, or we are running? What are we doing? Fantastic. That's a great webinar, and I thank the moderator as well as both the speakers. They have done a wonderful job. Thank you so much. Thank you very much. Thank you.
Thank you,
Thank
sir.
you. We have crossed the
Thank you,
time
sir.
limit. So thank you very much.
Yeah, thank you, Professor Sikdar, Atasi, and Nikhil for
Thank you.
enlightening the participants about the perpetual payment and the way forward. Thank you very much to IRF
Thank you.
for having organized this wonderful webinar. Thank you.
Thank you very much. Thank you.
Thank you.
Okay, bye-bye. Good night.
Bye, bye, sir. Good evening. Have a nice
Good
evening.
night. Good night, sir.